Hello everyone, my name is Philip, and today I'm going to talk about particle size determination using laser diffraction. Now to start things off, let's talk about why we need particle size determination. Now if you look at different industries, for example, if you're looking at pharmaceuticals, depending on the drug powders that we're making, you look at the drug powder and see what the size of the particles are. Because again, if you're using it in certain areas, for example, if you're using it in inhalation, you need to make sure that the drug powder size is correct. If it's too big, it's not going to go to wherever you want it to go. Or if it's too small, it will overshoot and it will not have its purpose. So that's why knowing the particle size is very important for each product that we make, especially for pharmaceutical drug products. Now let's talk about the typical laser diffraction analyzer. Usually consists of three components. The first one is the optical bench, which is the main instrument containing the laser where most of the measurements take place. Also, the second component is the sample dispersion unit. Basically, it feeds in the sample into the optical bench. And finally, the computer and the software, which does the actual analysis and generates the results for us to look at. So let's talk about the first component, which is the optical bench. Basically, it's a dispersed sample. Whenever you have that sample, you will pass it through the measurement area on the optical bench, where a laser beam will illuminate the particles. A series of detectors then accurately measure the intensity of light scattered by the particles within the sample for both red and blue light wavelengths and over a wide range of angles. So again, what you're going to do is you're going to take your sample, you feed it into the optical bench, the laser will hit the particle, laser signal will get scattered because of the particles, and then what you're going to have at the end is a detector that picks them up, and this is what generates the results for the particle size. Now, the other component, the second component, is sample dispersion units or accessories. Sample dispersion is controlled by a range of wet and dry dispersion units. These ensure that the particles are delivered to the measurement area of the optical bench at the correct concentration in a suitable and stable state of dispersion. Now, the key here is dispersion. Because when you feed in the sample, you need to make sure that the sample is evenly distributed and well dispersed. If you don't have proper dispersion of the sample, then what you're going to either have is very large particle sizes where you have the powder being clumped up together. So you're going to get an overestimate of particle size. Or you're going to disperse the particle too much where you're going to start breaking up the particles within. So what you're going to get is an underestimation of the particle size. So it is important that you choose a proper sample dispersion unit. Finally, we're going to have the computer and software. The software controls the system during the measurement process and analyzes the scattering data to calculate a particle size distribution. It also provides both instant feedback during method development and also some advice on the quality of results. So what it does is after the optical bench picks up all the signal, it's going to send the signal over to the computer and software, and what it does is it generates a series of calculations, and what you're going to end up with is a particle size distribution. So the following is one example of a particle size distribution. So what it does is it will plot out all the signals that it receives and generate a histogram like the one being pictured here. And it will show you over a range of particle sizes what the overall distribution is. And then based on that, we can use statistical analysis and we can get an idea of the overall particle size distribution of the sample that we're trying to analyze. So this is basically it for particle size analysis and determination using laser diffraction. Thank you for listening.